Hello everyone, in today's video we are going to see H61 voltage rails. So for that I have taken Gigabyte H61 M-WW motherboard. This is the schematic over here, and another is asus H61 M-C. Okay, so why I have choose these one schematics and one board view, because there is some sort of difference between these two motherboards. And whenever you are checking H61 motherboard, there are various companies producing them. So you will see there is some sort of varying architecture in each and every motherboard. You will be getting different supplies, and there will be some sort of changes in we core enable signal. So that's why I have taken these two case studies. So first of all, we will start with this asus H61M-C. So let me open it with my board view software. Okay, let me rotate this. Okay, this is the board view of asus H61M-. Okay, so first of all, whenever you receive any kind of motherboard, you have to start from RAM section. So this is H61 motherboard. So we support our i3 second or third generation processor. Okay, and the socket which is over here, which is LGA 1155. This is the socket number of this H61 motherboard. So starting from RAM section, so in this motherboard we are having DDR3 RAM support. So the operating voltage of this DDR3 is 1.5 volt first of all. So if you don't know how to check the which RAM should be connected, so for that, if you have any kind of motherboard, so just you have to zoom it over here. There is a blank space between this RAM socket. As you can see, this will be one notch and this is the second notch, and between this there is a blank space. You have to zoom on that, and here you will be getting here it will be written over, there will be operating voltage written over here, and in if it is DDR3 it will be 1.5 volt. It is if it is DDR4 it will be 1.2 volt, and if it is DDR2 then 1.8 volt will be written over there, and if it is DDR1 2.5 volt voltage will be written over here. From this operating voltage you can get to know that which RAM is supported by that motherboard. But by default each and every H61 motherboard supports DDR3. Okay, so and its operating voltage is 1.5 volt, so it should be written over here as a 1.5 volt. Okay, so let's start with RAM section. This is the this Asus motherboard has two RAM sockets. Okay, so as you can see, you are seeing here MOSFET pairs over here. So let's start. So first of all, this is the PL09, which is the coil which will be giving 1.5 volt, which is our RAM supply. So this is the coil where you have to check first thing, which is our RAM voltage, which should be 1.5 volt. So again, you can check this RAM supply. Whenever RAM is connected on RAM, you will be finding some SMD capacitors. You can check that RAM supply on that SMD capacitors also. Okay, this is the main supply which you have to look. So after that, we have to check some another supplies. So another supply is one point. So let me select this RAM. Okay, so first we have checked our RAM supply. Then next we have to check RAM VTT. In DDR2 you don't get any kind of VTT voltage, but in DDR3 you are having RAM VTT, which is approx half of that RAM voltage. Our RAM voltage is 1.5, so of course RAM VTT should be 0.75 volt. So pin number of RAM VTT is 120 number pin. Again 240 pin number is also there. On the both the pins you can check that RAM VTT. So here we have VTT DDR. This is the pin where you have to check RAM VTT. It should be half of that. So as you can see, it is near to this, means at the end of that pin. So that is the 120 pin number which should be over here. So at that point you have to check 0.75 volt. It should be present. Then next is 118 pin number. So as this is the 118. As you can see, this is the SM clock pin, which is again nearer to this pin, this end. So at that point you have to check 3.3 volt. Okay, then next is our SM data 238 pin number. Let me take 238 pin number. Okay, which is over here. Okay, again this is over here also. At same end you are getting this pin on 238 pin number. You have to check 3.3 volt, which is SM data. Okay, and last but not the least, on, okay, let me take it down. Okay, on last 236 pin number, this is the 236 pin number, you have to check SPD VDD, which would be 3.3. In RAM section mostly this SPD VDD is missing, that's why you get RAM beep or C1 code in diagnostic card, like that things are there. So if you get some sort of issues like that, you have inserted the RAM and it's giving RAM beep, then you have to check for SPD. If that voltage is missing, then you have to make a just jumper from 3.3 power connector, from 3.3 volt line to this pin 236 pin number. On backside of this motherboard you can just make a jumper, and by making jumper you can solve your problem. Okay, so let's check whether from which this supply is coming. This is the gate. Okay, we have here controlling PWM controller, which is controlling this, means this is controlling gate of this MOSFETs, which will be giving out as a RAM supply. Okay, so as you can see, this is the RAM controller, PWM controller. As you can see, PW8720, this is the name of number of that 8720 is the number of that controller. So whenever you get an issue that RAM voltage is missing, then just directly trace this gate terminal of each and every board. So after tracing this gate, you will be getting somewhere continuity over here. So this is the IC which you have to change. After changing this IC, you will be solving your RAM voltage supply missing issue. Okay, so in this section you will be getting this issue, either this RAM supply is missing or your RAM VTT is missing. This is the second issue, and third will be SPD VDD voltage will be missing. So this is the RAM section which you have to check. I will just call once again. First of all, in RAM section you have to check RAM voltage, which you can check on capacitor on the RAM SMD capacitor which are available, or on this coil. Okay, it should be 1.5 volt. So next thing which you have to check, RAM VTT, which should be half of that RAM voltage, which should be 0.75 volt. Okay, you can check that RAM VTT on 120 pin or 240 number pin of RAM socket. Okay, then next thing which you have to check, SM clock on 118 pin number, which should be 3.3. Next thing you have to check SM data, which should be 3.3 on pin number 238. Okay, and last thing which you have to check in RAM section, which is SPD VDD voltage, which should be 3.3, and the pin number for DDR3 is 236. Okay, this was all about the RAM section which you have to check. After that, we are coming to our PCH. As you can see, this is Pch architecture board. In G31 and G41 915 945, that series board will be having a hub architecture, and from this H55 we are having PCH architecture. PCH means this is the PCH over here, which means platform controller hub, means north bridge and south bridge are combined together to form a bridge. Okay, and this is our processor socket where our processor will be connected. So for working of this PCH, we need two voltages, which is 1.8 volt first is, and another is 1.05. So let's check whether where we are going to get those voltage. This is the first MOSFET. As you can see on this MOSFET, this is our drain terminal, and as you can see on drain terminal we are getting 3 volt. It is coming from our SMPS directly as an input. Okay, and in G31 we were getting 1.8 volt as an input, because uh, 1.8 volt was our RAM operating voltage, and right now it is 1.5, but we want 1.8 at its output, so it can be. So that's why they are taken 3.3 3 volt from SMPS, 3.3 volt from SMPS as the input to drain. Okay, so this will be giving output 1. Okay, 1.8 volt at this MOSFET. Okay, as you can see, this is going to our PCH. So let's check this 1.8 volt, who is controlling this MOSFET. So let me click on gate and let's check. Okay, only one component is over here, it may be the resistor. As you can see, PR137, just click one another end of that, and as you can see here, we are getting some sort of this. I think this may be the LM358. So let's check. Okay, as you can see, this is the ASM, means it may be called it is actually op-amp. So this number, this letters may be very LM should be there, or AS may be there. So there is no any kind of difference, but we have to check the number LM358, which is the operational amplifier which is going to control our this 1.8 volt. If what if this 3.3 is present and there is no gate supply? If gate supply will be not there, then this 1.8 volt will be also not generated. So sometimes you get problem like motherboard is tried to power on, it will fan will spin for 2 or 3 seconds, after that it will be shut down. So you have to check this voltage. If this voltage is missing, then only like those conditions will be there. For that you have to check this gate supply and just check, trace its path through board view. We can trace it easily, and as you can see, this is the LM35 which is going to control. And in most of the board in H61 series, you will get LM35 or LM324 which will be controlling. Just if you find any kind of this operational amplifier nearby this section, just directly replace it, because it is going to control, and most of the cases that is the fault, that is the main component which will be causing fault. So this is the 1.8 volt line. This is the second thing which you have to check. So next thing which you have to check, I think this may be that 1.5 volt. Okay, this is the 1.5 volt supply for species. Okay, let's see from where it is coming. It is on drain, the supply is coming from this MOSFET, and this MOSFET is getting supply from 1.5 volt. Okay, so DDR voltage is going to come over this MOSFET first, and it is going to this MOSFET, and this MOSFET source is connected to again this 1.505 volt MOSFET, which is be generating our 1.05 volt for PCH operation. So let's see, the gate of this MOSFET is controlled by, again, this is the resistor PR151. Let's check where it is connected. Again you can see LM35. Again, this is the MOSFET which will be controlling 1.05 volt supply line. That's why it is necessary. Sometimes this is the faulty component which you have to replace, and after replacing your this 1.8 volt line and 1.505 volt line will be again working properly. This is the MOSFET, and gate will be connected with, as you can see, this is the PCS. It will giving supply to PCS as well as our processor socket. Okay, this was about 1.05 volt line. So in this motherboard, as you can see, this was the first we have seen the RAM section, another 1.8 volt line, then this is the 1.05 volt line. So as you can see, these things we have seen. Next we are having these are the PL4, PL3, PL2 and PL6. Okay, these are some coils over here. So just let me click on this. As you can see, after clicking on this coil, you can see these three coils are for vCore. Okay, and let me check, this is the coil for JFX. In this motherboard, after whenever the vCore is generated, after the vCore generation of vCore, the whenever the display will be available, at that time only the JFX voltage will, means graphics voltage will be there. So for this VRM section, we should have some conditions, means for getting vcore voltage, we should have some condition. First of all, let me start from this vin section. Means first of all, our 12 volt line. Okay, this is the 4 pin connector from SMPS. It is 4 pin connector. So from that there will be two yellow wires and this will be two green wires. From that yellow wires we will be getting 12 volt on this connector, 4 pin connector, ATX connector. Okay, that supply will be going to drain of this primary MOSFET. This is the secondary MOSFET, and drain of secondary MOSFET is connected to this coil, and this output of that coil is given to CPU as a weak core. Okay, so this is the primary, this is the secondary, and gate of this primary MOSFET is must be connected to, here we have PR. Okay, these are two resistors. It is connected to, as you can see, is our core IC. Okay, so this is the supply. First of all, it will start from this SMPS, then it will be come on this drain of that primary MOSFET, and VRM IC will control its gate. Through that it will be dropping 12 volt to 1.2 or somewhere from 80 volt to 1.7 voltage, and that is the voltage range in which in between that Vcore voltage must be there. So it will be dropping from 12 volt to 1.2 volt at this point, and this is given to this coil over here, and output of that coil will be given to processor. Okay, so in some conditions, our Vcore is shorted. Means sometimes whenever you remove this 4 pin connector, your motherboard's fan will be continuously powered on, and whenever you connect, it will be spin for a few seconds and turn off. It means we have some sort of shorting in VRM section. So in this sections we have these three coils, means we have three phase power supply, and we have to check which are the MOSFET which are shorted one. Just remove that pair, means you have to just remove these two MOSFETs, and there are two MOSFET which will be generating Vcore, and at least one pair should be means two pairs should be there which will be generating our Vcore supply. So this is the main thing which you need to know about VRM section. Okay, so let's go to the with this VRM IC. For generating VRM's Vcore supply is necessary for CPU to power on. Is the operational voltage for CPU, and for generating that VRM's IC, these MOSFETs are controlled by this VRM chip. Okay, so let's check what is the number of that VRM chip. So as you can see, RT8876A, this is the number of that VRM chip. So this is going to control our VRM section. Okay, so let's start with this. So let's check enable signal first, from where that enable signal is coming. So let's find Vcore enable. Okay, this is the 34 number pin which is going to give us enable signal. Okay, so let me zoom in. This is the 34 number pin. So this chip must receive this enable signal to generate that VRM, means Vcore voltage. So let's check from where this enable signal is coming. We are going to see there are few components which are connected over here. So this is the component which I am interested in. So this is the first. It is a MOSFET, or it may be the PQ, means it is transistor. Okay, so here I am going to check this component which is PR130. So one terminal is showing as a Vcore enable, and another terminal is showing as a 1.05, means this is the PCH voltage 1.05 supply which is coming from this. So this is the enable signal. 1.05 volt is giving enable signal, which is used as an enable signal through this resistor. If this resistor is faulty, then that signal will be not coming over here. Or if one of this MOSFET, this is the MOSFET and this is the transistor, one of this transistor is faulty, then also it will be, if that this transistor is connected, means from this terminal is shorted with this terminal, then also it will be directly grounding that 1.05 volt. So you have to check this two, this is the transistor and this is the MOSFET which you have to check, and this resistor also you have to check if that Vcore enable is missing. Another, if Vcore enable is also available, and this VRM IC is not generating our V core voltage, then you have to check first MOSFETs. If all the MOSFETs are okay, then directly change this RT8876A from scrap board, or you may order that. So let's talk about this section over here, which is our GFX. As you can see, so it will be having two MOSFETs again and one coil. This will be primary MOSFET, which will be getting 12 volt from this ATX connector. As you can see, this is the primary, and output of that primary MOSFET is given to another MOSFET, which will be connected to coil, again same. In this through from H55 series, we will be having this GFX section. In G31 you don't have separate GFX section. In H55 and H61 will be having this. Sometimes you will be getting generating Vcore supply over here, but no GFX. Whenever display will be available, at that time only this JFX supply will be there. So before, whenever you will be getting no display issue, this voltage will be missing. So you no need there is no need to try to force on, means just make a jumper. You don't need to do that. For that you have to check your RAM section and all the other sections. You can try BIOS, because whenever the BIOS is faulty, then also our JFX voltage will be not generating. So you have to check those things. So whenever this JFX voltage is there, it means that your display is there. But sometimes you get JFX voltage and you don't get a display through VGA port. This is the VGA port, you don't get a supply through VGA port. In that case, you have to check the component which are over here near VGA port. So they may be the problem, root cause of that problem. You will be having display on VGA, so you have to just replace these components. After replacing these components, you will be solving your problem regarding the display. Okay, this was all about regarding asus H61 motherboard, in which we don't have CPU VTD because our PCS supply is given as a enable to vCore IC. That's why I have taken this case study. In some board you will be finding same structure. That's why I have taken this board. Okay, so next thing which are going to going to learn through this GA H61M-WW. So this is the Gigabyte very famous board, and in each and every Gigabyte motherboard you will be applying this knowledge, because in each and every Gigabyte motherboard you will be having same problem. So we will start from RAM section same. So for starting with RAM section, I will be just I don't have any kind of board view for this, but I am having schematic and I don't have any kind of photo. But we will start with our part number, means I am having the MOSFET number. So from that we will be finding. Let's start with RAM section. Q42 is the MOSFET which is connected in RAM section. Okay. Okay, as you can see, this is the first section, 1.5 volt section. This is the RAM section. So for that you can check Q42. This is the MOSFET which is connected in that RAM section, or L3 is the coil which will be giving 1.5 volt as a DDR voltage. So this is the one thing which you have to check. Again, I have told you the pin number of DDR3 RAM. So you have to check those voltage, means such as RAM VTT, SM clock, SM data, and SPD VDD. You have to check on that RAM. And for checking this means DDR supply, you can check on L3 or drain of this Q44. This is the section where you have to check your RAM supply. Next, this is the first signal which you have to check. Then we will go to Q24, which is 1.8 volt line. As you can see, this is the 1.8 volt line. So there is a LM324 which will be controlling this MOSFET, and for this they have given 3.3 volt. Again same issue, because we need 1.8 at output, and in G31 we get 1.8 as an input from RAM. But in this motherboard, the 1.5 volt means DDR3 RAM is connected, that's why 1.5 volt we cannot give as an input because we need 1.8 at a output, so that's why they are given again 3.3 volt through to this Q24, which is the MOSFET you will find near the PCH, and at output you have to get 1.8 volt, and for this MOSFET to work they have given LM324. It will be near to, means below the CPU socket, you have to check, because LM324 has 4 op amps, so it may be controlling various. See, as you can see, this is also LM324 which is controlling, means same LM34 is controlling 2 or 3 sections, that's why. So sometimes many times this LM324 is faulty in many motherboards, so you have to check that LM324 is working proper or not. So next is our PCH 1.05 volt. For that Q30 MOSFET is connected, so let me check where is that. Okay, so this is a 1.8 volt section which is going to PCH. Again this is the 1.05 supply. Okay, so there are two MOSFET Q27 Q30 which will be finding near PCH. So these are getting 1.5 as an input because 1.05 is less than 1.5, so we can give that TDR supply as an input, so they have given. In this case we can't give because 1.8 is greater than 1.5, that's why we have used 3.3 over here. So in this 1.05 section we have this DDR voltage as an input to this both the MOSFET, and again this gate of that is controlled by LM324, same IC, because it is having 4 operational amplifiers. So here you should get 1.05. In many cases this 1.05 or 1.8 voltage is missing, so you have to check. And this is also this MOSFET pairs will be available over PC nearby PCH. You have to check Q27 and Q30 pin, and this schematics is available on internet through which you can go. Okay, this is the next third voltage which you have to check. Next is CPU VTT. For that we have TQ1. Okay, this is the CPU VTT. Again you can check LM324 is going to control, means there are 4 op amps. So first was controlling 1.8 volt line, then second was controlling 1.05, and this is the third. Same op amp is controlling this CPU VTT. Again 1.5 volt of DDR is given as input for this TQ MOSFET. This MOSFET will be finding near, I think, below CPU socket. Okay, and output of this MOSFET should be 1.1 volt. On source we will be getting 1.1 volt. In many H61 motherboard we will be getting this issue, means this CPU VTT is missing, and for that most of the times this is the fault. Otherwise this resistor, means this is the voltage divider, this may be with the fault, so you have to check. Where I have received many boards with this register faulty, this LM324 faulty, and this that voltage divider circuit was not working properly. These are the three things which you have to check. And in, means whenever H61 is Gigabyte H61 any board is coming with you, and it is having it is spinning for a few seconds, and after that it is turning off, then 101% this CPU VTT is missing. So you have to check this LM324, and that for that you have to check this LM324 and all that. I mean, you have to check the gate supply is available or not, and whether it is coming for few seconds and going. If it is coming for few seconds and going, it's okay. You have to check next voltage. So this is the supply which you have to check on TQ01. This will be getting near below our CPU socket. It is, this MOSFET is available, so we have to check that. After that we are going to check VCCSA, and again this VTT power good is enabled for our VRM IC, so this is the most important. So we are going to check VCCSA. Again, as you can see, LM324 is going to control. This is the last op amp of that IC which is going to control CPU VTT. And VCCSA. VCCSA is the sub component of CPU VTT. That's why CPU VTT is given as an input. and this is the output. On this this MOSFET will be left side of that our CPU socket, which is MOSFET number Q13, which will be having 0.95 96 volt. As you can see, if it is high, 0.85 and 0.925 voltage should be there on this pin. Okay, this is the again important voltage. So sometimes our motherboard, we will be receiving this H61 any motherboard, and we will be having issue with, means our all the CPU VTT VCC SA will be also there, but when we check sorry, VCC SA will be missing, and when we check our VRM enable on our IC, and we'll be having means VRM enable signal will be not there. So for that, this is the section VCCSA power sequence section. You have to remove this MOSFET or this MOSFET. After removing these two MOSFETs, we'll be getting our enable signal to VCore. So you can, one thing which you can do, just trace the VRM enable pin on VRM IC. From that, keep multimeter in buzzer end, and you can check which component connected is connected to that pin. This component will be available beside the our CPU socket, left bottom left. So you have to check, there will be many transistors over there and MOSFETs. Just check which is going giving beep, and just remove that. After removing that, your VCore enable will be available and your display also available. Okay, so next is core section. We will be going to core section, DQ1. DQ1. Okay. Okay, this is not DQ1. Okay, this is the DQ1. This here will be getting 12 volt from ATX 12 4 pin connector, and here will be getting VCore supply. Again, this is PH1 and PH2 is going to our VRM IC. Okay, this is our VRM IC ISL 95836. Okay, so for this, let me show you VRM enable. This is the VR on, another name. Sometimes it is EN and sometimes it is VR on. So as you can see, the VTT power board is coming as a enable for this, and this is connected to any other transistor near that over which VCCSA MOSFET. Below that, we will be having some transistors. It is coming from that one of from that MOSFET. Okay, this is the section, and last signal which you have to check, which is GFX DQ13. Okay, this is the signal which where we will be checking GFX voltage, which will be near to 1.2 volt. So this was the basic in which we have learned some voltages regarding H61. So I will repeat in Gigabyte this motherboard, H61 motherboard. You have to check RAM section voltage, then PCH 1.8, then PCH another volt 1.05 volt, then CPU VTT which should be 1.1 volt, then VCCSA 0.92, then VCore 1.2, and JFX 1.2 volt. So sometimes you will be not getting GFX voltage. For that, you have to just do bias with the help of bias programmer, or in this each and every Gigabyte motherboard you will be having main bias and backup bias. You can remove main bias and just shift that backup bias to main bias place, and by which you can turn on display of your motherboard, and you can repair. This is the simple trick. Otherwise, if you are programmer, just copy backup bias and just flash it into main bias. By with the help of that, you can solve your problem. Thank you.